when you deal with nature of roots. Because when you think of the quadratic formula says x is equal to minus b plus minus b squared minus 4ac, right, over 2a. Now the idea is the part that's under the square root, this is the part that determines what kind of an answer you get, you see. So that's why when you deal with nature of roots, you will have to be careful, because this number here, this value can be one of three things, you see. It can be a number that is bigger than 0. It can be a number that is smaller than 0, right? And then lastly, it can be a number that is equal to 0. You see, one of three things. So with all that being said, the idea is, if you think of it logically, if this value here is equal to 0, it means that you will end up with two answers that look the same, because if you say whatever value here plus something or minus something, you will end up with the same value. So that's why whenever they speak of equal roots, you work this out, you see. Secondly, whenever they speak of non-real roots, you see, whenever they speak of non-real roots, you work with this one, non-real. The reason why you work with this one whenever they speak of non-real roots is because if this value here is smaller than 0, do you see that you end up with a value under a square root that is smaller than 0? Do you see that?
Yeah.
Of which we cannot have a value that is smaller than 0 under a square root. So that's why that would give us a scenario where you have no real solution. You see?
Yeah.
Yeah, so that's important. So with that being said, right, let us go back to to A rather, or before we go there, when they then ask for maybe real roots, right? When they ask for real roots, anytime they speak of real roots, then we would work out where b squared minus 4ac is bigger than 0, you see. Obviously, when they say real root and equal, then we mix the two. We'll have bigger than or equal to in our expression. We'll have, let's say, b squared minus 4ac, where is it bigger than or equal to 0? This is if they ask for equal roots, equal. Well, here they can say, not necessarily equal roots. They can just say, they can maybe say roots that are equal, or real and equal would just be this specifically, real and equal. You would just do this alone. But then obviously, if they just speak of real roots, you can also do this, because equal roots are also real. But if they strictly only want equal roots and no other exceptions, then you would work with this only. If they want real roots and non-equal, real roots, let's say here non-equal, real roots and that real roots that are non-equal, then you just work this one out. You see that?
Yeah.
So to add on to this, right, whenever they speak of cases where they speak of rational roots, rational, whenever they speak of rational, you need to show that b squared minus 4ac is a perfect square. When they say show that it is a perfect square, they just mean that show that it is a square number. You see, it's as simple as that, square number. You see, the logic behind that is that you see under this square root symbol, if this value here was a square number, do you see that the square root of a square number gives you like a whole number as an answer, right?
Yes.
Yeah. So if you had a square number under the square root, do you see that you would end up with square root of a specific number, which would then give you a whole number? The square root of a square number is a whole number. So that when you will say minus b plus a whole number or minus a whole number, you're bound to end up with an answer that's rational. Because remember, the simple definition of a rational number is a number that can be written in the form a over b. You see, meaning you can at least write it as a fraction. That's something I believe you also remember, right?
Yes.
Yes. So with all that being said, when you will be answering this question 6a, do you see that if they ask me show that the equation this has no real roots? So if you're gonna show that this has no real roots, let's see what you did here. You worked out what b squared minus 4ac is equal to, and you found out that b squared minus 4ac is a negative number. So yes, that's correct, because if that's a negative number, it means that you're dealing with roots that are non-real. The next one, they asked where this equation has two distinct unequal rational roots. So this is a big one, you see. The moment they mention rational, we should be thinking of, as we said, we should be thinking of the whole perfect square scenario. So with all that being said, right, let's see what we can have for b. We have to show that b squared minus 4ac is a perfect square. So two equal rational roots. Then we can say here, because delta is a perfect square. So you need to know this for when you will do it in other cases. You see, you just need to know that. So that's that. And then what else do we have here? Let me see here. Let's see. So the next one says we should work out where this equation has one rational root, so equal roots. So equal roots that are rational. So you work. So C is the one you said we should do. So with C, you took everything to one. You took everything to one side, and then you found out that B. You found out that delta is equal to 0. So you said you had two real equal rational roots. So in this situation, this is still fine, because if your value of b squared minus 4ac is equal to 0, like we said, it means you're adding a 0 and subtracting a 0 to try and attempt to get two separate answers, but you're going to end up with one answer, because adding a 0 or removing a 0, it won't change what you're starting off with. So that's correct. What you did for C is fine. What you did for B is fine, and what you did for A is fine. For D, it says we should show that this equation has two distinct unequal irrational roots. So with this one, let's see, you found out that B delta is equal to 37. So here, if you can add a reason, it will help you in the long run, because you will then know why you were doing what you're doing. So here we can say 34 is not a perfect square. Therefore, roots will be non-real. Roots will be non-equal, and irrational. So the roots are going to be real, but they're going to be non-equal and irrational. So you can say the roots will be real, comma, non-equal, and irrational. You see?
Yeah.
Yeah. So that's the way to do it. So it looks like for question number 6, there are no issues there. We can actually move on to question number 7, right?
Yeah.
Yeah. So let's see what we have here. Yeah. So with number 7, it says discuss the nature of the roots of this equation. So you have to determine what kind of roots we're dealing with on that one, which is fine, I guess. So let's see what we'll end up with, right? Question number 7. So if you're gonna find out the nature of the roots, right, it's quite straightforward, because fortunately you just have to find out what kind of a number b squared minus 4ac is going to be equal to. So our value for b here is -2 square root of 7. Our value of a is a 7, our value of c is a 1. So if you're gonna work out what b squared minus 4ac is equal to, I don't think we have an issue here. So let me just copy this. And then I just want to copy this so that we can just work with it at the bottom. So fortunately, as long as we have these numbers, I mean, we'll be like good to go. You see, we'll have practically anything that we need. So let's just carry on and see what we end up with. So make this bigger. Here it says where is delta? Delta is going to be squared minus 4ac, right? So what we need here is b, which is -2 squared root of 7, b squared minus 4, a is a 7, and then c is a 1. So we want to see what kind of a number this is. They're saying we should give the nature of the root. So meaning, you see, now we need to be able to interpret what our answer tells us. So here, if you put this in the calculator, it's going to give you, let's just put it in the calculator. Instead of me trying to work it out. Looking at there. Sure. -2 square root of 7, the whole thing squared gives us 28. Okay, so it's 28 here, and then minus 28 also. So delta is equal to 0. What does that tell us about our roots?
It tells us that it's they're unequal. No, they're real equal rational roots.
They are real equal rational roots. Nice, nice. Real, equal, and rational roots. Nice, nice. That's 100% correct. That is 100% correct. You see. Yeah. So that's fine. Let's move on to the, let's see here. Let's move on to the next. So that was that for this. I think we can stop this one here. And then we can move on to what you want to look at next. Let's do this.